In this problem, we have to find the force in the members Hg, He, and De of the truss and state if the members are in tension or compression. So, you see, we can use the method of joints or the method of sections to find the force in these three members, but method of sections is the best way to find forces if we are given a limited number of members. So first of all, we have to draw a section line between these three members, and you can use the left side or the right side of the section line, but let's see, we can use right side because it is easy if we use right side of the section line. So this is some theory related to the method of sections. If you are interested, then you can go through it. You see, this is the forces in these members, and we can also draw the free body diagram of this part of the truss. So you see, we can use the equilibrium conditions to find the forces in these members. So first of all, if we apply the summation of moment at point E, so we get the force in member Hg, and it has a perpendicular distance of 4 feet from the point E, and we get the force at point F that is acting vertically downward, so we get 1500 and perpendicular distance is 3 feet. And you see this force rotates the truss in clockwise direction, so it means it is negative. And while the force in member Hg rotates the truss in the anti-clockwise direction, so it is positive. And you see we get the force in member Hg that is 1125 pounds, and the force produces tension in this member. And if we again apply the summation of moment at point H, so we get force in member DE, and it has a perpendicular distance of 4 feet from the point H. And we have the force at point E that is acting vertically downward, and it has a perpendicular distance of 3 feet. So this is this. And we have force at point F, which is again 1500 pounds, and it has a perpendicular distance of 6 feet like this. So we get the force in member DE that is 3375 pounds. And you see we get a negative answer. You can also put negative sign here. So it means that the force in this member produces compression. So now we can apply the summation of forces in the vertical direction. So we get the force in member HE. You see, this member acts like the hypotenuse of a right angle triangle. So we have a base of 3 feet and a perpendicular of 4 feet. So if we apply Pythagoras theorem, so we get hypotenuse that is 5 feet. And as the force is acting in the vertical direction, so we have to use the sine component, and sine component is perpendicular over hypotenuse, so we get 4 over 5. And again, we get the forces, vertically downward forces at point E and F. So these forces are negative. So we get the force in member EH that is 3750 pounds. And the force in this member produces tension.